Okay, let's solve question number 2 of tutorial number 3. The number of requests reaching an email server per second has a Poisson distribution. So we already know that this one has a Poisson distribution with a mean of 2.3. So the parameter of Poisson distribution can be described either as the mean or variance of it. Doesn't matter because both of them are equal. So from here I understood that lambda, the parameter of Poisson distribution, is equal to 2.3. So you can show it like Poisson distribution with just one parameter. For binomial distribution, we had two parameters, n and p, and for here we have just one parameter. But both of them are discrete distributions anyway, so they act very similar when you want to calculate them. Now in the first question, the probability of receiving no request in the next second. So every information is related to seconds anyway, so you don't need to have any conversion there. So we don't want to use such tricks that often for our questions, but because I want you guys mostly learn about how to calculate probabilities and how to find them on tables. But in some books you can even find some exercises related to give the information in seconds, then ask for hour. We should be careful about it anyway. So if you don't know how to deal with them with just a simple ratio, please also let me know. So we will go through them as well. So the probability of receiving no request in the next second. No request equal to 0. That's the question. So since it's a pointwise, it's easy to calculate it. You should know about the formula for Poisson distribution. So whenever you want to calculate the pointwise probabilities from Poisson distribution, you should follow this formula. So this constant number, which is an irrational number, usually you can approximate it by 2.7 in our course. If it's not given to you, then you can use 2.7. That's good enough. So e power minus, so here we should have lambda, which is 2.3, and lambda here is powered by x. Oh, by the way, I wanted to first show you the formula before assigning the number. So in general format, e minus lambda, lambda power x, x factorial. Okay, so this is the general formula. Now we want to calculate this one. So probability of x equal to 0 should be from this Poisson distribution with lambda equal to 2.3. We have all the information. So e minus 2.3 and lambda, which is 2.3 power 0, and 0 factorial, which is equal to 1. So you should find the final answer here, which is e power minus 2.3, and by considering 2.7 instead of e, you can find the final answer. So don't give this one as the final answer. You should still calculate it by 2.7 power minus 2.3. And as you know, the final answer should be a value between 0 and 1 because this is the probability. Okay, next one. The probability of receiving less than 3 requests in the next second. But before going through that, it's not a bad idea to also show you about the reading tables from Poisson distribution as well, because I will also show you that in another video. So assume that I want to read it from the table. For case of 0, this is exactly equal to this cumulative version because we don't have any value less than 0 for x. All of them should be 0 or more than that. So in that case, I can even read it from the table easily because both of them are equal and you can read it from the table since it is less than or equal 1. So if you don't see it right away, I show you here again, 0, 1. And for Poisson distribution, which is a big difference with binomial distribution, we don't have upper bound here. Why is that? Because we don't have any value for n in Poisson distribution. We have only one parameter. Okay, so it goes to infinity. But less than 0, we don't have any value. So doesn't matter if I show it like 1 point or 0 and less than that. Okay, so I guess it's obvious. So for the second question, the probability of receiving less than 3 requests in the next second. Less than 3. So again, like binomial distribution, this is a discrete distribution for Poisson. The only difference is that you should use different formula for each point. So you can just partition it into points like x equal to 0, x equal to 1, x equal to 2. Does 3 included? No, because it is less than 3. So one by one, you should calculate them and then find the final answer. And here, I know that this is a Poisson distribution, so use the formula for Poisson distribution and provide us the formula as we did in the previous slide, okay? You should provide this one and also show us what's the distribution. Okay, so in case of reading from the table, less than 3, I cannot read it from the table directly because it doesn't have equality at the same time. So this one I can write like x less than or equal to. Now I can read it from the table. 3 itself is not in the calculation, as you can see. Okay, for question number 3, the probability of receiving more than one request. So if it was a binomial distribution, for us, it was easy to consider it pointwise from here, because you would say, for example, x equal to 2, x equal to 3, and we reach, for example, 5, and that was the way. But for Poisson distribution, it goes to infinity. You cannot calculate the infinite number of pointwise probabilities. So what to do? 0, 1, 2, and goes to infinity. So for each point, it's not possible to calculate it infinite times. So what I can do is that now we are asking you about more than 1, consider it less than 1, and calculate the complement of that. That's easy. So 1 minus, again for complement, let's practice here. So when this is more than, it should be less than. So change the direction of inequality. These numbers and variables are the same. And this one doesn't have equality, so this one should have. Okay, so here it's easy to calculate the rest. So this one is easy, right? When I want to use the formula, then I should consider the pointwise probabilities for 0 and 1 and calculate the final answer. And when it is related to reading from the table, again, the same trick. Use the complement. And since this one can be easily found on table, then you can read the final answer. Yeah, I mean, read it from here, then calculate it to show it for the final answer. Okay, for last ones. For Poisson distribution, it's pretty easy because we know that expected value, which we can show also with mu like this, can be equal to Ex. So mu is equal to Ex, and mu is equal to lambda equal to variance of x. You can also show it by sigma. Little by little, I'm trying to show them with different notations because we are going to use them, especially when we talk about sample and population of a distribution, so it could be very useful. So we know that for Poisson distribution, mean and variance are equal to the parameter of Poisson distribution. So very fast, I can say for Ex is equal to 2.3, the variance is equal to 2.3. But if we ask you about the standard deviation, how to calculate it, it's very easy. You already know about the variance is equal to 2.3. Then standard variation is equal to square root of 2.3. Okay. So for these two questions, they are equal to exactly lambda. If we ask you a standard deviation, which we didn't ask here, you could also calculate it by this easily. Okay, so let's continue in the next video with the third question.